Hopefully you already wrote this. You are titling it Experimental.
Why are all your classes scheduled? You decide to record this one?
I just record this 7th grade class usually.
Why?
I don't know.
Because.
Okay, so experimental probability. What is experimental probability?
Because we have more questions about life.
No, we have more questions about why you talk so much.
I used to do it in Tristan's class because then Tristan wouldn't talk.
Right.
I didn't want to be recorded. Blake.
The way like it's actually worked out.
Yeah, what actually happens?
What actually happened? Oh! So this was more like physical.
Yes. I guess.
What?
Is volleyball physical?
What do you mean?
Is volleyball physical?
What do you mean?
You like just said volleyball is not physical.
I don't think so.
That graph that I just gave you. The little tiny handout that I took time to cut out. You are going to glue that right underneath. So right here will be your graph.
Give me a glue stick.
I got my
Say,
music friend.
Alright. Give me a glue
Friend.
stick. He finally gave me a glue stick.
You're about to drive train saying, stop.
Don't drive Trey insane. We need him to tackle the QB and then drive the QB. Do it!
Damien!
I am still recording.
Okay. Hi, my name's Damien. How's your day going?
Example 1. You should have it glued by now. It wasn't that big to glue.
Awesome. How many subs
I
do
don't
you
know how to glue.
Well,
Good for you.
have?
probability of glue.
You better get you to at least 500.
Okay, I'm moving on with or without you. Some of your classmates would like to be able to hear me, so maybe zip it. Okay, so example 1, we're going to figure out the experimental probability of spinning and landing on blue. Your graph shows you the results of a spinner. Okay? How many times did you spin and land on blue?
15.
15.
15, right? If you look at the graph,
Wait, they're all the same?
15. Yes, they are all the same.
Do we glue this right next to it?
No, I haven't told you that for a reason because we're moving on. We haven't gotten to that yet.
Yeah, we.
Okay, so 15 out of, when we find experimental probability, it's the times that it actually occurred over the total number of times the experiment was conducted. How are we going to figure out how many times this experiment was conducted, Claire? Out of the numbers. So how many times did you land on green?
24.
21. Plus, how many options did you land on blue?
15.
Plus, how many options did you land on red?
24.
So how many total times did we spin the spinner?
60.
60.
I
Guys.
got
That's after age. Okay, so we had 15 times we landed on blue. How many times did we spin it total? 60. Can that be simplified?
No.
Yes.
Yeah.
Yes. By what? By what?
15.
By 15.
1/4.
Yeah, I'm not emailing.
15 divided by 15. 60 divided by 15.
30.
4.
I saw 15. and
What
I
is
went to
1/4 as a decimal? 25 hundredths? What is that as a percent?
What do we do with the little wording?
Dylan, I haven't gotten there for a reason. Just set it down. Okay, if I was to ask you the probability of red, how could we figure out the probability, the experimental probability of spinning and landing on red? Julia. Good. I'm going to erase part of my work because I'm going to run into it.
That could be simplified, can't it?
Yes. What do you want to simplify by?
Go.
I'm going to do 4 first. If I divide the top by 4, 24 divided by 4 is
Like
6. 60 divided by 4 is what?
30.
15.
I said 30.
15. Okay, can those both be simplified?
Yes.
By 3. 15 can't be divided by 2.
Oh, I forgot about that.
6 divided by 3 is 2. 15 divided by 3 is
5.
so 2/5 is the reduced fraction. What is that as a decimal?
0.4.
Miss Addie, you better have all of this down. 4/10, and then what is that as a percent?
40%. Oh.
Kaden. You can. I just wanted to show that sometimes when you simplify, you have to simplify again because it's still, there's still factors that go into it. So yes, you could have done it by 12 to start with.
We're going to
Yeah.
do green next.
For this, you want to have the name to divide, you could just times the denominator and numerator by 2, and you would get 4/10, and that would be.
Yes. Yep. Questions?
So how is it not 20?
What?
How is it not 24?
How is it not what?
For the decimal.
Because 2 divided by 5 is 0.4. Questions on this? Okay, the next example. Now, you can take the other handout, the little cutout, the words, and paste it right below there.
Paste it where?
Right below what you just wrote.
Can I put it under the spinner results graph?
That's where you put it.
Oh, I thought you could put it under where you just put it.
My stick broke.
Why don't you
Can you borrow your, just throw it away, borrow your neighbor's?
Why don't you
Wait.
Okay, I'm moving on. Your voices are off.
It's okay. So
Damien, do you want me to start the time?
No.
and you know something?
Jada.
Quiet.
And
Guys, quiet.
You guys need to be quiet. This is not social hour. Jada, you do not need to turn around. Okay. The problem says 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? Okay, so our probability of 9, it should say sum of 9. Sum of 9. How many times did we spin it, or how many times did we roll it and actually get a sum of 9? 8. Out of how many times did we roll the dice? Can that be simplified?
yes,
By
by
what?
4.
Yep.
So 2/5.
Yes. Which is what as a decimal?
0.4. So
4/10, which is the same as
40%.
40%. Okay, now, if you look over, so my last part of this is comparing theoretical and experimental. So we're going to compare the probabilities.
Comparing. Is that how you spell probability? Because it looks really long.
Yes.
For how it's pronounced. Or is that just me?
So on the page before, on page 17, we actually calculated the theoretical probability of rolling a sum of 9. What did we get? So you're going to have to look at page 17. We calculated the theoretical experimental, what was it? What? 1/9. What was the percent? 11%. It's probably easier to compare the percents when comparing probability. So we have 11% for the theoretical. And we're comparing that to the experimental, which we just found was 40%. So when you're comparing, what options do you have for answers? Greater than, less than, or equal to. So what is our answer going to be for comparing theoretical to experimental?
40 is greater than 11.
Correct, 40 is greater than, but if we're reading it this way, what is our answer going to be?
Less than.
Theoretical is less than experimental. So then your final thing that you have to write on that page is a sentence, a complete sentence. So if we were comparing the theoretical to experimental, we would say that the theoretical, so you're writing this down, the theoretical probability,
How do you spell theoretical?
look on page 17, the theoretical probability of rolling 2 dice,
Wait,
the theoretical probability of rolling 2 dice and getting a sum of 9
wait, on the same paper? Yep.
is less than the experimental probability. So you should have a complete sentence comparing them. The theoretical probability of rolling a dice